Okay, so we start at the NWP buoy, right there. And we are headed down to Dana Point. Okay, as you prepare, you review the local notice to mariners and see that you're reporting a new lighthouse. So that's just like a correction to the chart. So we are adding in a new lighthouse. Now remember, this is just for training purposes. This is not a real lighthouse. We're naming it fictitious lighthouse. And it gives us a position. So we have 33 degrees, 32.9. I'm going to get that one in, 32.9. And 48.3. Can you see that? No. 48.3. So right where it says to Rock Point, that is going to be our new lighthouse. So we can even draw in our light symbol. Okay, so we have our new light. You plan to leave the NWP buoy at 0800 and set course for 120 degrees PSC to Dana Point with a speed of 5.2. What is your DR position when you pass a beam of 2 Rock Point? Okay, so they told us our course that we are steering per standard compass. So we need to convert it to true to plot. So we have compass, and that would be adding east minus west. We have a compass course of 120. We go to our deviation table. With a compass heading of 120, we have a deviation. What deviation do you guys see?
Four east.
4 east.
Yep.
And it's east, so we're going to be adding that. We have magnetic of 124. Variation we get from the chart, 12 east. East again, so we're adding. And we get a true of 136 degrees true. So now we can plot that. Find my pencil. So from the NWP buoy, we are going 136 true. So I just have my pencil on the NWP buoy, and I put my focal point on the meridian, and I have 136, and I draw in my line. So this is my course line, and it asked, when am I going to be a beam of 2 Rock Point? So I have my pencil on 2 rock point. You get a 90 to my course and just draw it in. So when is this? Or what is your DR position and what time? So it's both. What is the position and the time? So to get the position, our latitude, we are close to the edge, so I'm just going to use the roll plotter. We are 31, 32.1. The longitude, 11749.2 or 3. And then we need the time. So to do time, we need distance. The distance of 4.1. Distance is 4.1. Speed is 5.2. What is the time? What'd you guys get for time?
8:47.
Yep. That would give us 47 minutes. If we left at 8, our ETA would be 8:47. So we have 100 plus 47, 08:47. 8:47. So that was just a practice of getting position, really just plotting positions and plotting our course. Okay, so this one is going to be our regular fix and getting our actual speed over ground. Okay, so at 8, let me erase. So at 8:38, which would be before this, right? This is at 8:47. So a little bit before that, we take a fix and we get the NWP to being 313 degrees true. And our two rock point, which is our new light. Oh, that is our new light. So rock point light bears 065 degrees true. So we need to plot in those LOPs for a simultaneous fix at 8:38. So from 8 or NWP, we have 313. And then from our 2 rock point, we have 0.65. Okay, let me zoom in. See it a little better. Okay, so where these two LOPs meet, that is my position at 0838. Now it asked me what was my actual course over ground and what was your actual speed over ground. So our course over ground, because the buoy we left was the buoy we got a bearing of, we already have our course over ground drawn in. We technically already have the bearing of it, but we can get it again. So if I was here and I'm going this direction, my bearing of it would be so my course made good is 133 degrees true. So on that line, this direction is 133, where this direction, our bearing of it was the 313. Now for speed made good, we need to get our distance. Distance of 3.8. So if I have a speed of, what was my speed? Oh, I'm looking for speed, right? And my time was 38 minutes. We have 3.8 and 38. So we have 60 times 3.8 divided by 38 gives us speed. Our speed gives us 6. So our speed over ground is 6 knots, where we thought we were doing 5.2, but we are going a little bit faster. Number 6 says record your position. So we want to get the lat and long so we could record it in the log. The longitude of 49.4 for your 4. And then my latitude was, where did I mark it? Right here. 31 to 32.4, 32.5, somewhere around there. And then it said, are you on your original DR line? No. And why? Don't really know why. Possible wind and current would be our answer for that. So any questions on getting a fix and then calculating our speed made good and course made good?
Can you explain the difference again between course made good and speed made good?
Yes. So we have this this is where we were at 0800, and we have what we think we're doing. So this is what the boat is assuming. We are having a course of, we calculate our course to be 136 and a speed of 5.2. So with that, we got a position, or we can calculate a DR for here at, what time did we get our fix? Was 8:43. 8:38. And then we got an actual position somewhere around here at 8:38. So this is what we call course made good, speed made good, or course over ground, speed over ground. Those mean the same thing. So what actually happened was where's my little eraser? Here we go. Here's my little boat. We set on this course, but we actually never went on it. Our wake has always followed that pink line, even though our course was set for 136.
Okay.
So then if we connect the triangle, this is our set and drift, which we're going to go into next week. So the line from a past position to a new position is where your wake went, where you actually traveled from an old position to a new position. Even though your boat was heading something else and the speed was chugging along at something else. Your speed made good and your course made good can be something different.
Okay, thank you.
Hey, Bree, can you show me your course over ground, how you got the heading on that?
Yes, so because on this actual question, my bearing came from the same position, it was the same line. I had a bearing like that or something like what our bearing was. So we measured that line. So if I go back to here, a minute anymore right here. Okay, so I have this as my bearing line. This was my track line, my DR line. So
Right.
This was my bearing line, and I wanted to know what was my made good. So if I was here at 8 and here at 8:38, I needed to connect those two positions. They're already connected because that's what I took my bearing from. And then I can measure it. And I get 133. So if I'm going this direction, it's 133. Where in the problem, it told me I had that bearing of 313. because I'm down here and it's at 313, north of me. But my course made good, I'm moving to the south, to the southeast.
Right.
So my course made good is 3133. I think I had it like, so this was our 08, 0838. So this direction is 133. This direction is 313. It's the same line.
Okay.
Just okay. Now we plot a running fix.
But I've got a question on that. If those are reciprocals, I mean, I would think that they would be like, they would somehow relate to 360 and like 313, it would be.
So it's 180 plus or minus.
180, okay, yeah, okay.
Yeah. So 180 plus 113 gives us.
Okay, I got it. Yeah. I was thinking of a full circle instead of half a circle.
So it's just the reciprocal, yeah. Okay. Okay, so now we do a running fix. The fog rolls in after plotting our 838 fix. You decide to steer further away from shore, so you change course to 140 PSC at 5.2. You are still concerned about your position at 856. You get a bearing. At 838, you get another bearing, plot your running fix. Okay. So we need to convert all of these to true. So we are steering, so we're going from our compass. Yeah. So we kind of did this, I don't know, week 2 or 3. So we had a heading. And then we're going to have the hospital. And then we're going to have 2 rock light. Okay, so our compass, we are heading at 140. Our hospital is bearing 103. And our 2 rock light, no, our 2 rock light we already have as true. Oh, we're using our other LOP, that's it. So 065, okay. So we need to convert these two to true. With a heading compass of 140, our deviation is, what is your deviation?
East.
To east. If it's east, we're going to be adding. So we have 105 and 142. Variation is on the chart at 12 east. We're going to be adding that again.
Hey, Bree,
Yes?
The deviation on the hospital isn't 2 east, it's 5 east.
So remember, it goes from your heading,
Oh, that's right.
not the bearing. Yep. Okay, so 42, that's, nope, can't do math in my head. 5, 154, and 17, 117. Okay, so that up here so then you can see me plot. I've lost my pencil. Okay. We are plotting South Laguna Light bearing 117. So we find South Laguna Hospital, which is right here. And it is bearing 117. I can't do that. Okay. Okay, so I have 117 on the focal point and on South Laguna Hospital. So I can draw in my LOP. I'm somewhere along that line. And for my 2 rock point, I had changed course to 140 from this position. So let me get 140, no, 154, excuse me. Okay, so I have my LOP at 838, and I need to advance it to this LOP at 856. See how far we advance it. We have 18 minutes. We are going at a speed of 5.2. We're looking for distance, and our time is 18. So what is our distance? We have okay, so I got 1.56 nautical miles. 1.56. So from my line where it crosses my my DR line, which it starts at, I can swing an arc. So I just tick that line, and then I need to parallel this line. I Just look at parallel, easier to see. So I parallel this. And this line is now my 838 to 856. And this is my 856 line. So where those two 856 lines meet, that is where I'll be at 856. So something is really pushing me closer to shore. The current and the wind are coming up. All right, how'd you guys do on this running fix?
A little complicated, but
Yes.
just gotta
yes.
work. We gotta work problems, I think.
Yep. Work it a couple times. We'll have another practice on our final one.
Bree, I think that the time interval between the taking two, two fixed, right, or two measurements has to be really small to keep that accuracy, right? If you the time interval between the two is too long, then accuracy will be sacrificed or compromised. Is that the correct statement?
Yes, because the further you get away from your known position, the more things are going to affect you. The more set and drift will affect you. The more steering error will affect you. The more, things can happen. So the further you get away from your known position, the further out your kind of window of where you think you are. It gets more blurry.
Yeah, the closer you are to being lost.
Yeah. Okay. So this gets a little more confusing. Okay. Well, let's do it. We finish that. Okay, so we have at 856. From your 856 running fix, you drift for a while, deciding what to do, and decide to change course to 160 PSC. At 928, you decide to head further offshore. Okay, so that's the same thing, and steady on 160 PSC. I'm just gonna delete that. You decide to take a bow and beam bearing fix. You see the building in Dana Point bearing 315 relative, and you are motoring on a course of 160 PSC at 5.2 true. At 10 o'clock, you see a beam. You are careful to hold your course and your speed. You are confident you can get a good fix. What is your bow and beam fix? Okay, so we have changed course to 160 PSC. So we need to change that to true. And then we had we saw it on our bow at, why can't I see the time here? Oh, 09:28. And then we saw it on the beam at 10. What is our bow and beam fix? Okay, so we need to convert this guy to true. So I'm gonna go from compass at 160 PSC to true. So I use my deviation table.
0.
To 160, 0. Yeah, I think I said that. So we have 0, 160, and then our magnetic was 12 east.
12 east, yeah.
East is we're going to add, so we have a true of 172 degrees true. Okay, so we can plot our 172 degrees true. One 172.
Hey, Bree, what do you, oh, okay, I see.
What was it?
How'd you do that triangle fix again?
Okay, yeah. So I had, because it's close to vertical, it's harder to reach. So I just put it on the white so it's easier to read. Focal point on the line, and then 172 on the line on a meridian.
Okay.
And then you use the short side of the triangle, put something straight, ruler, whatever, and then you can parallel it to the line in question.
Okay, so you line it up, you made a 172, put your ruler there, and then it allowed you to move down to your fix off of 2 Rock Point.
To your 856 fix.
856 fix. Yeah, that's off the 2 Rock Point, right? Oh no. That
It was
is,
from the hospital and then a running fix from 2 Rock Point.
I see what you're doing. Okay.
Okay, so
So 172.
so we have our course, and we were using the building in Dana Point. So that's this guy. And I'm gonna get a beam bearing. So my beam bearing would say I'm somewhere along that line. But I know I drifted for a while, so I don't know exactly where I am. We have to find out the distance run is equal to distance off. So our distance run between 928 and 10. So we have 10 and 928. That gives us 32 minutes. Plug that into our 60 D Street. We have a speed of 5.2. Distance is what we're looking for, and time is 32. What do you guys get for distance?
$2.7.
2.7. We got 2.8.
2.8. 2.77.
I'm gonna call it 2.8, 2.77. So I'm somewhere along this line. Now I have a distance off of 2.8. 2.8. From my building. I have a bow beam position right there at 10 o'clock.
You just took your compass and measured 2.8 out from your,
Correct.
okay.
Hey, Bree, can you show me how you got that building line?
Yes. So I used my triangle. What tool are you using?
Triangle.
Okay. So I put the course line on the 90-degree line.
Okay.
And then I put my pencil on the building
Okay.
and I drew the line.
That's it, huh?
And a beam is always going to be 90.
Yep.
Okay.
Simple enough.
That was easy.
Nothing's ever simple, right?
Okay.
Okay. And then it asked us what was our position, so we can get the lat and long. And then on the fathom curves, what are we between? So remember our fathom curves, and we have the numbers up here.
200 and 250?
Yep, 200 and 250.
Hey, Bree, why was the 315 degrees mentioned for the building?
Okay, so the 315 is relative. So that means it's a bow bearing. So we are cruising down here at, what were we doing? 1-1. We're doing 117? No, sorry, we're doing 172. Okay. I was looking at the wrong question. Okay, so we're cruising this way at 172, right? Now, when we do relative, we always start from our heading and we go clockwise.
Okay.
So that is our 315 to the building. which is also, you know, our 45 to port instead of starboard.
Oh, okay.
So
Oh,
it asked us,
okay.
it actually asked us, number 10, what was the true bearing of, what was the true bearing here? So if due north is 0 and my heading is 172 plus my 315 gives me a really large number, or I could subtract my 45 from my 172. Either way, we want to know what the true bearing is. So that would be from true north to the line in question, what is that angle? So we kind of have a little puzzle on our hand, right?
Yeah.
What's the missing number? So we can do two things. If we go with my R plus S equals T, we get our relative, which was 315, plus our ship's heading, which is 172, equals a really large number, 487. So that means we went from north all the way around plus another bit around. So in order to get that, we have to minus 360. And then we get
127.
127. Or we could have gone 172 minus 45. And that also gives us 127.
So you did 315 as your relative, and then you did plus 172. Is that your S?
Is that your what?
You got 315 plus 172.
Yes.
So that's relative plus true?
Relative plus ship's heading equals the true bearing.
Oh, ship heading, okay. Is 127.
Okay, so our next little section, last section here. Weather is still a factor, so we decided to just come into Dana Point, which was our plan all along. But we want to stay for the night. So we come left to 100 PSC. And at 10:25, we see the building and this buoy in line. And then we also see the cross. So we're getting a position at 10:25. So we need to calculate our position or change our information there into true, so we can plot it. So we have our heading and our cross. We started it with C. Oops. So our heading, we changed to 100. And our cross was bearing 038. So our heading was 100, so we go to the deviation table.
Five east.
5 east. Yep. 5 east. It's east, so we're going to add. We have 105 and 43. And then our variation is 12 east. So that is 117 and 055 degrees true. So that's what we're using. Our truths. So we have our 2 lines of position here. One, we didn't get an actual number. We just got a visual range. So how do we plot that? Is we just, let me try to zoom in on this again. See that? Better? Okay. So, triangle here. We first see the visual range of the building and the buoy in line. So all we have to do is connect those two. And we know we are somewhere along that line. And then the other piece of information was the cross here was bearing 055 true. Page here. So hold on real quick. Cross and 5, 5.
What are you setting the bullseye on your triangle on?
So I extended my my lineup.
You can do that, huh?
Oh, okay.
Yeah. You can do it from this one and then move it over. I guess I'm taking a shortcut. Ooh. So I have a 1025 and I am headed 111.
Hey, Bree, can you show me how you got that cross line again?
Yes. So Did you extend this meridian?
Yes,
Okay. So I put my pencil on the cross,
okay,
and then I aim for my focal point to be on the meridian,
okay,
and then I move it around until I get 0, 5, 5. So pencil still on the cross. Looking for 5, 5 and focal point. So I got the focal point up here, 0, 5, 5, and my pencil on the cross.
okay, 0, 5, 5. Okay. I see what you did.
So I'm right next to that buoy.
Yeah,
Headed into Dana Point. Okay, so it asked us what our position was. And then it said, how far did you cruise between these two fixes? So that's going to be your 10 o'clock and your 10:25. So if we go over ground, we could connect those two lines. It didn't ask us for a course over ground, but I connected the lines anyways. We get our distance between these 2 points. Almost 3. We'll call that 2.9. Distance is 2.9. I'm looking for what my speed over ground was. So what was my time? This was 10, and this was 10:25. So I have 25 minutes. On the chart there. Oh, let's do magic.
Seven,
What speed did you get?
7 knots.
7 knots.
6.
7 knots. So we just get more and more practice with our plotting, right?
so, hey Bree, so the story is at 10 o'clock, the skipper changed heading to 100 degrees
Correct.
PCS, and then at 10:25, the skipper saw that the buoy in the building was lined up.
Correct.
And he could also see the cross.
Correct.
And so that gave him a fix
Correct.
just off the buoy
Yep.
by about half a mile, less than that.
Yeah. Like 3/10 of a mile.
Yeah.
Amazing.
Now, a lot of times in our recreational boating world, if we pass very close to a buoy, we can just call that buoy our position. And,
You say close, like within a half mile, or?
I would say maybe 2/10. I like to say 2/10 is my rule of wiggle room. Try to get your fixes within 2/10 of the answer, kind of thing.
Okay.
Yeah, that's a little over 1,000 feet. You should be able to see that.
Yeah. And of course, if you are,
3 or 4 football fields.
you know, navigating in close waters, maybe you're going to bring that back down to less than 1/10. But
Yeah, if you got swells, right?
yeah, it's all dependent. And if you look up, oops, uh-oh. Sorry. Let's see if I can switch this around. Yeah, okay. You look up at the top of the chart. Put it around my house here. This is the, the chartlet for Dana Point. So we could, we don't have the building on here, so we couldn't have plotted that range. But I just wanted to point out on here, we aren't in tenths of a mile. We're in minutes. You guys see that?
Mm-hmm.
Yeah.
So on the big chart, our latitudes look like this, and we're in tenths of a mile. Here, we have, what is that mile? Is a mile? That doesn't make sense. This is a half mile. Oh, yeah. So this is 57, and then seconds, 10 seconds, 20 seconds, 30 seconds, 40 seconds, 50 seconds, 60. So this right here is a mile. Anyways, I just want to point that out. Okay. What else do we got here?
Hey, Bree. Quick question.
Yeah.
Why, for the deviation for both the cross and the building and the buoy, why did we use 5 east for both the 100 degrees and the 38 degrees?
So our heading is what we go into the deviation table with.
Got it.
Not the bearing.
Okay.
So we always go in with our heading. So our deviation is based on our boat and where our boat is pointing. If we didn't change our boat, we kept our boat pointing the same way, we just got a bearing.
Okay.
So there's that difference between heading and bearing. Let's see. Let me get my paper out of here again. I was going to ask Janice, are you with us?
Taking a nap, I think.
Janice?
Well,
Yeah, I'm here.
Okay. Did you want to talk a little bit about plotting for sailing for me
Sure.
versus
I can
power
do
boat for
that.
sailing?
Um,
Might draw a picture of it.
yeah, I'm sorry I didn't respond. Sometimes my audio is not real good. If you're plotting a course for sailing, it's not really too different from when you're plotting courses for power. Where you get into issues that get kind of more complicated is if you have to go upwind and the course that you want to sail is directly where the wind is coming from. So if the wind is coming from due north and you want to sail due north, you can't sail that direction. And that's what they describe as the no, I think they call it no-go zone. And that's kind of new terminology. For me, it was just, you can't point that high. So, but that no-go zone is usually about, if you've got a really well-tuned up boat with good sails and a nice hull design, you might be able to sail as much as 45 degrees from the center of the wind on either tack, starboard tack when the wind is coming over the starboard rail, or port tack when the wind is coming over port rail. And less tuned up boats that are more typically used for like weekend bopping around and cruising, that ability to point up into the highest point that you can sail would be about 60 degrees off of the center of the wind. And I've even sailed on boats where we were happy to get 70. So, I mean, we were doing a close reach and we were real happy about it. So what you're going to end up doing is to go in the direction that you want to travel against the wind. You have to sail a zigzag course. And what you'll do is try and stay as close to your intended course as possible. But you're going to have to sail away from it. And just as Bree's demonstrating, you're going to be zigzagging to go upwind. If you're in the smooth waters, probably either tack would be about the same. But when you get out in the ocean and you're dealing with waves and swells, sometimes you'll find that you're just cutting across the swell on a better angle on one tack than the other. And so you might find that you make actually better speed on the tack where you're getting a better ride over the swells. So what you may want to do is stay on that better tack, and it may be more comfortable. You know, if you're going to be doing it all day, you want to be comfortable so that you don't get too tired and all that. But what you may want to do is do a long run on one tack, do a short run on the other tack to kind of bring you back to your intended course line, and then go back over on that more comfortable tack. The reason I suggest that you don't stray too far from your intended course line is because the wind will change direction. And sometimes you get a really significant wind shift, and it might be in your favor. So if you've gone way away from your course line, your intended course, you may have to sail a lot of extra miles to get back to where you could have been if you'd stayed closer to your intended track. So if you happen to get that really favorable wind shift and you happen to be near your intended course, it just, you know, it's nicer, it's faster, and you get there sooner. Let's see what else. You have to keep track of these tacks. So every time you tack, you need to plot a new DR course. And it's a really good idea to plot out or hour so that you have an idea of where you're going to be at these intervals. That can help you decide whether or not you'd like to tack. So if you were traveling on the orange course that Bree is plotting, the dead reckoning shows you good points at which you might want to plan a tack. And then same for the green as well. The other thing that will happen, especially in the waters around here, in the mornings the wind tends to be very light. This is more like summertime conditions, but the wind tends to be very light, almost non-existent. And then it builds throughout the day, and in the afternoons you have a pretty strong breeze. as that wind builds, to west southwest, or you know, usually doesn't go too much past southwest. But you know, I worked at Catalina, and sometimes in the mornings I would have a wind that was out of the west, I'm sorry, out of the east. And then at noon the wind would totally lay down and die. And then I would get a west wind in the afternoon. But I was working very close. I was doing a tour along the east end of the island, so I was within a couple miles of the shore. I was in a powerboat, but I noticed the wind. So you can get pretty radical wind shifts. Also, if we've been in Santa Ana conditions and those are starting to break down and go back to our normal sea breeze, what can happen is you can end up with winds, offshore winds, and then you may have a period where there's very little wind, and then the sea breeze fills in from almost a completely opposite direction. So, so that's another thing that would cause you to have totally different wind conditions over the course of the day. But usually you don't get that much variation. And you would, if you were sailing and there was any chance of Santa Ana conditions, you would know that because you checked your weather forecast before you headed out. That's something to pay careful attention to. Let's see. If you are sailing dead downwind, say the wind is coming from, instead of north, it's coming from the south, and you want to go north, so you've got the wind completely straight behind you. Sometimes, depending on the sail plan that you have for your boat, that can be a little bit of a rolly situation. And especially if you don't have the right sails for it. And so sometimes what people find is it's actually better to sail a little bit more of a broad reach than dead downwind. So basically what you do is you sort of tack downwind, and so you would be doing a zigzag course to follow your intended course line. So you might sail with the wind coming, you know, a few degrees over your starboard quarter, and then you would either tack or control jibe, and have the wind coming over your port quarter. And what that does is sometimes it just gives you a little bit better angle on the swell, and you might get a little bit more speed out of it. You're traveling more distance, but you might have less rolling, and it's just a little bit more comfortable. And if you're going to be doing it for several hours, it's something to consider. Any questions? Does this stuff make sense?
Yeah, makes sense.
Yeah, that was great, Janice. Thank you
Yeah.
very much.
Oh, you're welcome.
Yeah, Janice,
Do
I have a kind of expanded question. I never used the autopilot. I assume the autopilot for sailboat can only work as long as you don't need a tack, right? As you remain at one tack, you can rely on the autopilot.
It really depends on the autopilot and how it determines the error. There's different methods of like when the boat gets pushed off course, and how the autopilot determines how much you got pushed off course, how much to correct to get you back on course. If you've got a good system that doesn't overcorrect, then you can use autopilot when you're sailing. And I've there's a brand that we used. It was called Benmar, but they're not out there anymore. But we used it sailing quite a bit. But I have seen autopilots that if they went too far off course, if say there was a wind gust or a big swell kind of pushed the boat around, the autopilot would go too far to bring the boat back on course. And then that caused if you were sailing close hauled with your sails in tight, sometimes that would cause the boat to go into the no sail zone or the no go zone. And then the boat stalls, and then you can.
Hello, Janice?
Have a good autopilot. It can be done. You do absolutely have to have somebody standing watch, and it's not, for other vessels, but also just to make sure that if the autopilot is set to follow a certain course and your wind changes, you may be able to take advantage of that slight wind change, but you've got to be there to notice it and take action on it. If you're using a wind vane, which is a way of using the point of reference for the wind vane is the wind itself, and it steers the boat at a particular angle to whatever the wind is. If the wind changes, the wind vane will allow your boat to stay at the same angle to that wind, but it may put you off your compass course. So either one of them, you really have to monitor and make sure that that you adjust as needed.
So the autopilots only control the rudder, right? Not control the sails.
That is correct. Yeah. The autopilots are usually set up to work through the rudder system, and a lot of them have their own compass. So you dial in a compass course, and then the autopilot will steer to that course.
All right. Well, thank you, Janice.
I'm hearing a lot of noise. Was there a question out there?
Oh, I just said thank you. That was information.
Oh, okay. I'm sorry. Yeah, my internet connection is not very good, as you know, and so sometimes I don't hear anything at all, and this time I didn't. I just heard some funny noises. Yeah, it's the other thing that is good to know, and it's the.
Uh-oh, now she's breaking up.
Than power boats, they sometimes really feel the effect of a current setting against them. So, or if you happen to get into something like the Gulf Stream, it's like you put turbochargers on the boat if you're going in the same direction as the Gulf Stream. So knowing how to cope with that is always good.
Currents and wind. Speaking of currents, next week we are going to go into a little bit of the set and drift practice. So the homework for this class we did in class, right? All of assignment number 14. The next assignment is the final assignment, which I recorded a tutorial today, so I'll have that posted in the next day or so. And I'm not going to go over that in person unless you have some specific questions. I can do that next week. But next week, I'm going to focus on some set and drift exercises.
Oh.
So a little bit off the curriculum there, but I'll send you a PowerPoint on Sunday and some extra practice problems. And that's what we have planned for our last class.
Great.
All right. Well, let me know if you guys have questions along the way, and I'd be happy to help. But that's all we got for tonight.
Okay.
Okay.
Thanks, Bree.
Thank you.
Good
It
night,
was
everybody.
good.
Thank you.
Thanks, Bree.